Alrighty, now time to talk about our last type of quantitative display, the box plot. And you might have heard this called the box and whisker plot back in middle school, but this is used to communicate information about the 5-num sum. And so of course it's not actually called the 5-num sum, it's called the 5-number summary. And you've already experienced this. This is actually a part of our summary statistics. This is the min, quartile 1, quartile 2, quartile 3, and maximum. So those are the 5-number summaries that tell us certain positions in the data. Now, using the distance between the 5-number summary, we are able to determine the quartiles of the data. Remember, 4 quarters is $1. 4 pieces of 25% of the information of these 25% sections equals 100% information. And very similar to histograms, we lose individual observations. And that's just because this is an overall summary of the quantitative distribution instead of the individual summary from like the box plot or the stem plot. However, we are given approximate locations of the 5 numbers, and those 5 numbers are the 5-number summary. And also due to the whiskers, we can see the presence of any outliers. Consequently, we're not able to see any distinct gaps or peaks, meaning we cannot see specific types of shapes, and more about that shortly. So when we talk about the box plot and when we cuss at a box plot, we're actually going to use the median and the quartiles, or the IQR for our center and spread, because those are easily seen. So for example here, I want you to label this on yours. Here's the min, here's the first quartile, here's the median, or quartile 2, here's the third quartile, and here's the maximum. So in this box plot here, I don't know if there's 1,000 observations, I don't know if there's just 5 observations, I don't know if there's 1,000,007 observations. All I know are these 5 numbers. And sometimes these numbers aren't even a part of the actual data because remember, it measures a specific location within the data. And as we've seen previously, when you have an odd number in your sample size, or I think it's even, you're going to end up a little bit wonky and you're going to end up in between values. So even these 5 numbers are kind of unreliable. So we just need to take that into account when we're analyzing box plots. Now, your x-axis is going to have an equal scale, including a label and title, very similar to our dot plots. Now we're going to draw lines at each of the values of the 5-num sum. The IQR here is actually denoted by the box because Q3 minus Q1, well, notice that is where the box occurs. The whiskers connect the minimum to the first quartile and the quartile 3 to the maximum. And then any outliers are either going to look like a star or a point or something, but it's not going to be a part of the box plot. It's going to be a little bit a ways from it. And so it'll be denoted there on your graph. And speaking about shapes, remember, we have 2 categories of shapes. We have approximately symmetric, and then we have skewed distributions. And then within those approximate symmetries, we've talked about unimodality, bimodality, and uniformity. Now, look at the histogram here. You can see there's one distinct peak, but when I look at it in the box plot, I can't really see that peak anywhere. Or when it's bimodal, yeah, I guess I could tell that the box, right, or the quartiles here seem larger than the rest, but again, I couldn't tell you where the location of those peaks are. Or if it's uniform, everything occurs exactly the same. Notice that each of these portions appears almost equidistant, but I can't see the specific shape. All I can see is the symmetry. So when we describe box plots, we're only going to focus on approximately symmetric, skewed right, or skewed left, since again, I don't really know the other types of shapes, or I can't really see them here. Now, we've talked about back in lesson 1.4 describing the data. So we can actually, if we have the individual observations, we can find that 5-num sum and create a box plot. So the unique thing with box plots is it's very easy to get to these from stem plots and dot plots. And same goes for histograms. So it's easier to go from dot plot, stem plot to box plot, histogram, but much more difficult to go box plot, histogram to stem plot, dot plot. So just keep that in mind as we're working through these graphical displays. So let's take a look at an example here. And the following report shows the number of minutes that 60 customers spent at a 5-star Thai restaurant. Fun fact, Mr. Pinto's favorite cuisine is Thai food, because I'm a proud accidental vegetarian of 4 years. I'll tell you more about that story later. But guess what? The manager lost the receipts, which contain the total amount of wait time. So these are the only values he recalls off the top of his head, and we're going to determine if there's any outliers present in these wait times. So I could at least form the box here with the quartiles, but I need to determine which of these is the minimum and the maximum, or if there are any outliers. So the first thing we need to do, using our IQR rule, is that we need to determine the IQR by finding the third quartile minus the first quartile. So 50 minus 40 is going to give me 10 minutes. And actually we weren't given units, but I'm assuming it's minutes. I wouldn't assume you ate in 80 seconds. That'd be impressive, but not today. We'll do Q1 minus 1.5 the IQR, and we'll do Q3 plus 1.5 the IQR. And here that's going to look like 40 minus 1.5 times 10, which will give us a lower bound here of 25 minutes. And so anything less than 25 minutes would be considered a lower outlier because, so a wait time of 15 minutes is considered a lower outlier since it is less than the lower fence of 25 minutes. Here, let's see if there's any upper outliers. So I'm going to take 50 plus 1.5 times 10. So anything above 65 minutes is going to be considered an upper outlier, so greater or less than. So here's 65. We have an upper outlier at 80 minutes for wait time since this exceeds the upper fence of 65 minutes. So just remember, you're answering, you're providing context, and you're explaining why. So these are outliers because they're outside of the fence values. Well, now that we have our 5-num sum and a clear indicator here of some outliers, we can make a box plot here. But what needs to happen is we need to create a scale here. And so on the AP exam, you only need 2 values, but we're just, we are good statisticians, so we're just going to focus on things like this. So here we go. Here's 20, 25, 30, 35, 40, 45, 50, 55, 60, it's kind of close together, my bad, 65, 70, 75, 80, 85. All right, so now let's go ahead and mark our values down. Well, we determined that 15 and 85 minutes were outliers, so I'm going to put a star here, or actually a dot, which indicates outliers. Okay, next up, let us go ahead and mark the minimum. So since 15 is an outlier, the new minimum becomes the next known observation. So for us, the next known observation is here at 25. That's our minimum. Same thing goes for the maximum. The 80 was an outlier. 80 was an outlier, so whatever known value that is less than that is going to be now the new maximum. So for us, the next known value is actually here at 65. Quartile 1 occurs here at 40. Quartile 2 is here at 45. And quartile 3 occurs here at 50. So I'm going to connect my lines here because this is my IQR. That's my box. And then I'm going to connect my whiskers. So my box plot looks kind of like that. And again, we could argue it's like skewed left, skewed right, depending on which outlier has more pull on the data set. But notice that 80 is 15 above 65 and 15 is only 10 below 25. So maybe the upper outlier might have more pull on the data. But when we look at the shape of a box plot, we're only going to focus on the box. So my box here looks approximately symmetric. And just a quick note, so if you want to make a quick little picture for yourself here. So we're going to call a box plot that looks like this. We're going to call that skewed to the left. Or if it has a large tail to the left, which the opposite now holds true. If we see that a majority of the data happens here on the right, or there's a large tail to the right, we're going to call that skewed right. But other than that, we're just going to keep it pretty simple there by just looking at the box, the visual representation of the IQR. Alrighty, so of course now it's time to describe the wait times. Well, we already have the median and the IQR, and we've addressed the shape, and now anything unusual. So you can see these problems become very intuitive after a while here. So let us check this out. So the dining times have a median of 45 minutes and an IQR, or interquartile range, of 10 minutes. The distribution of dining times appears approximately symmetric, and there are 2 outliers. One lower outlier at 15 minutes and one upper outlier at 80 minutes. And there are 2 outliers for the dining times. More context never hurt anybody. Context, perfect. We've talked about dining time in minutes. Center, we talked about our median. Unusual, we talked about the 2 outliers. Shape, we said approximately symmetric. And then our spread, we talked about the IQR. Now, one thing we just talked about was that the box plot gives a visual representation of the 5 num sum, right? So I can use the locations here of the quartiles, which means here between the minimum and the first quartile is 25% of the data. Here's 25%. Here's 25%, and here's 25%. So I can find what proportion of the data, how many customers there are based on its location here. Now, this only happens if it falls on a quartile. For example, I can't tell you like what proportion was less than 37, because 37 isn't exactly one of my nice quartiles. So let's take a look here. How many customers had a wait time between 40 and 45 minutes? Well, between 40 and 45 is 25% of the data. And we were told that there were 60 customers. So if I have 25% of 60, that's going to look something like so. So I should have 15 customers had wait times between 40 and 45 minutes. So again, there's usually a follow-up question that they'll ask you with box plots. So we just talked about constructing them, describing them, and then using the quartiles to find out more information about your data. So again, what I'm going to need you to do now is to pause this video and practice describing data, practice making a scatter plot, and then applying what we know about shape to a follow-up question. So go ahead and pause the video, try your best, and we'll come back together shortly to figure these out. Alrighty, the following box plot shows the amount of money in dollars that a typical teenager puts away in savings after their birthday. Describe the savings. Now notice I do not have the actual values, so my wiggle word here is going to be approximately because I'm approximating. Like I don't know if that's actually 110 or 111. I don't know if that's 150 or 152 because the scale here is very minimal. So we're just going to use approximately as our wiggle word. So the distribution of savings has a median of approximately 150 with an IQR of approximately $60. And the distribution of savings appears skewed left with no notable outliers. So we're just cussing out the data. Here I had a set of 15 values, and of course 15 plus 1 is 16, divided by 2 is 8. 8 is not my median, but the 8th observation holds my median. And then once you have your median established, you're going to cut your data in half, and then you're going to take the half of the upper data and the half of the lower data to find the quartiles, and then min and max are pretty easy. So I can see here this box plot, and rest assured we will practice this using the Delta Math platform, and you're going to be so good at making box plots that it won't even hurt anymore. And then lastly, based on our shape here of the distribution, notice that the right half of the box appears fuller, and then the tail on the right hand side also looks longer. So based on the shape of the distribution, we would expect the mean to be greater than the median since the distribution appears slightly skewed right. So we answered and we gave an explanation. There's no context here, so we're not going to worry about that. But that's actually going to conclude our lessons here on displaying quantitative data. So now we can do dot plots, stem plots, histograms, box plots, and we can calculate summary statistics. So the last thing we have to do is we've been looking at one sample. So we need to talk about what happens when we look at multiple samples. So in our last lesson of this first half of the unit, we're going to just be dealing with comparing quantitative distributions. So stay tuned.